Individual biomass systems can range from simple pellet stoves and log stoves to heat a single room, through to boilers big enough to heat a community centre or a school. At the smaller end of the scale, buying a biomass boiler is much like buying any other heating system. You'll want to obtain several quotes and make sure that the installer is reputable. Check reviews, ask for references, and determine whether they are registered with the Microgeneration Certification Scheme. Even at this small scale, the first thing you'll need to consider is fuel supply. Where will it come from? Is it a reliable supply? And do you have the space to store it? Pellets for pellet stoves require very little storage space, but they are more likely to come from further afield, so it might not be convenient to get small quantities. Log stoves will require a constant supply of firewood logs, needing more storage space, but it's likely that you'll be able to get them very locally, so you might be able to pick them up yourself in small quantities. Once you start looking at bigger boilers, the sort that could heat a whole home, or even larger single boilers to heat a school, a place of worship, or a community centre, planning the installation will feel more like a project and less like the purchase of a domestic appliance. But the first thing you need to address will still be fuel supply. The Forestry Commission's Biomass Energy Centre website contains a list of fuel suppliers by region, so it should be the first place you consult for information. If your building is fairly near to a local farm, sawmill or estate, it's also worth contacting the estate office to explore the options for local supply. If they don't already produce wood chip, they may be willing to start if you can guarantee them an ongoing market of sufficient quantity. However, you'll need to make it clear that you need wood chip that meets a certain specification. The sort of wood chip produced with a forestry chipper is often not of the right size and uniformity. For this, a specialist wood fuel chipper might be needed, and they'll need to be able to guarantee a fairly standard moisture content as well. Starting with the heat demand of your site, it's relatively easy to roughly estimate what annual quantity of fuel you might need. Start by looking at the site's space and water heating bills over the last 2 years. This will indicate the typical amount of energy that is needed over a year, and you can convert this into tonnages of wood fuel. Wood chip is normally supplied with a moisture content of about 35%. 1 tonne of this will provide around 2,900 kilowatt hours of heat energy. Pellets, on the other hand, are drier and more dense, so a tonne of pellets will give you around 4,800 kilowatt hours. If your bills show that the space and water heating of your building was around 17,400 kilowatt hours per year, then you need about 6 tonnes of wood chip or just over 3.5 tonnes of pellets. Wood chip and logs are likely to be delivered by lorry, so if you have difficult or narrow access, you could be limited to pellet systems, which could come by van. In addition, wood chip and logs take up quite a lot of space, whereas pellets require far less. So if storage space is an issue, pellets may be the best option again. Wood chip needs about 4 cubic meters of space per tonne to store, compared to just 1.5 cubic meters a tonne for pellets. Once you have some basic estimates of likely tonnages, you've considered what sort of vehicles might get to your site and where you might build or adapt a fuel store, then you can discuss your options with local fuel suppliers. It's important to make sure your annual supply of fuel will be of a consistent and reliable quality, free from contaminants like soil or even nails. Most important is to make sure that the moisture content and particle size of the wood is matched to the boiler specification. Wood chip boiler manufacturers refer to standards for the size and moisture content of the wood chip that's suitable for their boilers. These will be either UK CEN or Austrian ONORM standards. You should ensure that the contract for fuel supply that you establish specifically notes the size and moisture content your boiler will accept, and it should refer to these standards for clarity. You can find useful contract templates for wood fuel supply on the Southwest Woodshed website. It's really important that you establish a formal contract of supply rather than an ad hoc approach to purchasing. This will ensure continuity of supply, fixed costs over a certain period, and will give you redress against a supplier who provides substandard fuel. It's also worth verifying where the wood is sourced and whether this may change in the future. The type of system you install will depend on many variables: the available fuel supply, size of the heat demand, resources for maintenance, and whether you want hot water as well as heating. All of this can be discussed with suppliers. Just remember, it's best to get at least 3 quotes to compare systems and costs. Here are some questions you ought to ask first. Many biomass systems, especially when there's no other source of heating, are now specified with an accumulator hot water tank. This acts as a reservoir, storing heat when demand is low and then releasing it later. This can give you more flexibility in sizing the boiler and could reduce costs depending on the pattern of heat demand in your building. But the hot water tank can be quite large, so you need to discuss where it will go with the installer. This depends on the delivery options available. If access is easy and there's lots of space, a simple tipping trailer vehicle can drop wood chips straight into an underground store. But if you have limited access, there are ways to use an air blower system, where wood chip or pellets are blown in through a flexible pipe. Health and safety requirements will also need to be considered, such as who will supervise during deliveries. How will you ensure that the fuel store is secure and won't let in water? The boiler house might need to be a new structure, but if you are replacing an old coal or oil boiler, it's very likely you can use the same location. If the site or building is listed, you might need to spend extra on hiding or designing fuel stores and boiler houses so that they're in keeping with the building. Depending on the pattern of heat demand, a biomass plant can operate in tandem with fossil fuel plants such as a gas boiler. This way, the biomass boiler functions as the lead boiler, supplying the larger proportion of annual heat demand, and the gas plant supplies additional heat during periods of high demand. It may be economically more sensible to do this rather than having a bigger biomass boiler that is working under capacity most of the time. Compared to gas, biomass systems require more work. Supervising regular fuel deliveries, performing regular maintenance checks and disposing of ash. Maintenance checks and ash disposal can be undertaken by trained on-site personnel, but servicing is normally carried out under contract with the equipment supplier. For small-scale biomass heating, disposal of ash will normally be needed once or twice a fortnight during peak heating periods. The amount of ash produced by wood chip corresponds to less than 1% of the delivered biomass by weight, which means that on-site disposal is possible in some cases. Compared to gas or oil boilers, biomass boilers use more electricity for their motors, fans, augers and pumps. The difference, particularly on large systems, can be significant and are often overlooked. So make sure you ask your installer if their calculations have included such costs. The height and location of a flue will mostly be determined by building regulations. So for sensitive sites, such as listed buildings, your options may be limited. The overall financial viability of your scheme will depend on many factors, including fuel costs, operational costs, and the impact of the forthcoming renewable heat incentive. A strong business case will require a quite detailed appraisal of costs and benefits. Note that operation and maintenance costs are generally higher than for equivalent gas systems. They can be minimised by increasing plant automation, automatic ash extraction for example, but these will probably increase your capital costs. Unless it's a small domestic system with no significant fuel storage or flue, the answer is almost certainly yes. For systems designed for a single building, gaining planning permission should be fairly straightforward, but be prepared to be flexible. For example, you may have to consider an underground fuel store if permission cannot be granted for an above-ground one. A wood-burning stove for heating an individual room will normally cost £1,000 to £1,500. A biomass boiler for a large house will cost between £15,000 and £20,000, and a 250 kilowatt boiler for a large public building could be in the region of £200,000, including the costs of building a fuel store. But you'll need to speak to installers to get an accurate figure, as costs are very site-specific. The price of the fuel can also be variable. Wood chip is a very localised market, but is currently between £70 and £100 a tonne in most areas. For the convenience of pellets, you pay extra, around £180 to £230 per tonne. But it's better fuel, so you'll need fewer tonnes. You'll need to order a minimum amount to get these prices though, normally about 3 tonnes for wood chip, sometimes less for pellets. Small quantities will cost you more than buying in bulk. Hopefully, you've now got a better idea of what wood fuel systems could be suitable for you. Thank you for watching.